Example 1. A particle of charge q and mass m performs a circular motion in a uniform magnetic field B. Show that the period of the motion is given by t equals blah blah. So, we firstly consider a circular motion of a charge under a magnetic field, okay? So, suppose that we have a charge and the charge is moving with velocity v, like this, okay, under a uniform magnetic field B, okay? So, using the right hand rule, okay, so if I use my right hand here and then I represent the velocity by my index finger, and then I represent the magnetic field by the middle finger, okay? So my thumb will be the force, okay? And the direction of the force in this picture, okay, will be going up, okay? So there will be force going up in this picture too. And then when the force is pointing into the center of the circle, your charge will be making a circular motion, okay? So we can write down the relationship between the force, okay, which is the force from the magnetic field, and also the force from the magnetic field will be the centripetal force. So the force from the magnetic field can be written in terms of QVB, while FC center force is mv squared over r, okay? So if I cancelled one of the v terms here, what we get is we have the radius of the circle as r equals mv over qb. So that's a common formula for the circular motion of the charge under a magnetic field, okay? But this time, the question is asking you to prove for the period, okay? So when we consider this time period or t, okay, one period is essentially a motion with one circle, okay? So your charge is making just only one circle, okay? So for one circle, what is going to be the distance? So the distance will be the circumference of the circle, which is s equals 2 pi r, okay? And one period of time, okay, would be equals to t, okay? So that we can write down the speed v in terms of s over t, or 2 pi r over t. And then what I can do with that is I will just plug in this speed, okay, back into the r equals mv equals q over qb. So that I will have r equals m over qb, and then times by this 2 pi r over t, okay? And then I will cancel r with r, and then I will move the period t to the left hand side, and then what I get finally will be the time t equals 2 pi m over qb. So that is our conclusion, that we have proved that the period t is 2 pi m over qb.